Hi guys, in this video we're going to talk about solutions and graphs of linear inequalities. Let's start with solutions of linear inequalities. Linear inequalities are inequalities in two variables, most of the time x and y. Any ordered pair is a solution to a linear inequality if the point makes the inequality a true statement. So for equations, we know that there are solutions of equations or linear equations that makes the equation a true statement. It's the same thing with linear inequalities. Any ordered pair that makes the linear inequality a true statement is a solution for that inequality. Let's take a look at our first example. We have y greater than or equal to negative 2x plus 5, and we're trying to find if these solutions are possible solutions. So the first point that we have is 1, 3. And to be able to see if this point satisfies the inequality or not, I'm going to substitute y with 3 and substitute x with negative 1, or with 1. So I'm going to end up with 3 greater than or equal to negative 2 times 1 plus 5. So this will lead us to have 3 greater than or equal to negative 2 times 1 is a negative 2 plus 5, that's a 3. So we have 3 is greater or equal to 3. This is a true statement which makes the point 1, 3 a solution for this inequality. Now, for the next point, we have a 5, negative 1. So again, I'm going to substitute y with negative 1, and I'm going to substitute x with 5 to find out if we have a true statement or not. So I'm going to end up with negative 1. I know that negative 2 times 5 is negative 10 plus 5, that's a negative 5. So I'm going to end up with negative 1 is greater than or equal to negative 5. Which is again a true statement. That means 5 and negative 1 is a solution for this inequality. Now, for negative 5, negative 2, again, I'm going to substitute y with negative 2, and then I'm going to substitute x with negative 5. I'm going to find out if I have a true statement or not. So I'm going to end up with negative 2 greater than or equal to. Negative 2 times negative 5 is 10 plus 5, that's a 15. So I have negative 2 is greater or equal to 15, which is definitely not a true statement, which means negative 5, negative 2 is not a solution for this inequality. So the two solutions that I have here is 1, 3, and 5, negative 1 for this inequality. Now let's graph this inequality. We need to, when we graph the inequality, we need to make sure that it's in the slope y-intercept form, which it is in this case. We have y isolated, which means I'm going to be able to identify the parameters. And the parameters are the slope and the y-intercept. The slope in this inequality is negative 2, and the y-intercept is 5. To graph this inequality, I always start or begin, B is for begin, with the y-intercept. So I'm going to begin with 5, graph 5. So I'm going to graph 5 on my line, and I'm going to use the slope to graph my other points. I know that my slope here is negative 2, 1. I know that negative 2 is the difference in the y. And when I have a negative value, that means I have to go down 2 points or 2 units. And then I have 1 for the difference in the x. And since it's positive, that means I need to move to the right. So my next point is going to be 2 units down, 1 unit to the right. And I'm going to continue graphing my points to be able to graph the boundary line. So for equations, we have lines, and for inequalities, we have what we call a boundary line. And we call it a boundary line because when we have greater than or equal to, and when we have less than or equal to, we make a solid line. And we include the solutions in this on this line. But when we have greater than or when we have less than, we make a dashed boundary line. which means the solutions on this boundary line are not included. So I have a greater than or equal to, which means I'm going to make a solid line, a solid boundary line. All the solutions on this line are going to be included. Now, I address the equal part of the inequality. I need to address greater than. I have y is greater than negative 2x plus 5. So to be able to include the values that are greater than, I need to look at my y-axis. On my y-axis, I need to shade the values that are above my y-intercept. So I'm looking at my y-intercept here, and I'm trying to find the values that are greater than 5, which is which are the values above the line. That means I'm going to shade these values because any solution or any point in this shaded area is going to make the inequality a true statement. So I'm shading this area that includes every point that satisfies the inequality above the boundary line. And this shaded area is called half plane. So the shaded area is called half plane. And the line here is called a boundary line. And the solution is in the half plane. And if we have greater than or equal to, or less than or equal to, the solutions are also included on the boundary lines. So when we have greater than or equal to, or when we have greater than, we shade above the line, above the boundary line. And when we have less than or equal to, or when we have less than, we shade below the line to include the values that are less than the y-intercept. Now, in the previous example, we were looking at 3 points. We were looking at 1, 3. So 1, 3 is right here on the boundary line. And this point, based on the graph, is supposed to satisfy the inequality, which it did satisfy the inequality. Now, the second point was a 5, negative 1. And 5, negative 1 is right here, and which again, this point satisfies the inequality, and it's in the half plane of the graph. Now, the last point was negative 5, negative 2, and negative 5, negative 2 is right here. And this point is not on the boundary line, and it's not in the half plane, which means it's not a solution. So to be able to write 3 points that are in the solution set, I'm going to put down the points that we had from the previous slide. 1, 3. I'm going to put 5, negative 1. And then I'm going to choose another point. I'm going to choose this point here in the half plane, which is 6, 3. Now, now let's see how the TI-84 can help us graph this inequality. So the first thing that you have to do is you have to put the inequality in the calculator. So I'm gonna press y equals, and the inequality has to be in the slope y-intercept form. I'm gonna put negative 2 x plus 5. And then instead of the equal sign, I need to move the pointer to the left to go all the way to this line next to y equals, to the left side of the y equals. And then I need to hit enter to find the choices for the inequality. So I'm going to go down and I'm going to choose, this is a line. I'm going to choose the sign greater than or equal to, which is this one. So shading above the line, that's greater than or equal to. And I'm going to hit enter. And then when I graph, the calculator is going to show me the graph of the inequality. So in this case, as you notice, the calculator will graph the inequality for you and show you exactly where the shaded area is.